In this video, we will look at how to filter geometric entities in the model using attribute queries. Before we get into filtering, let's do a brief recap of getting and setting attribute values, and getting entities. Both of these have a shorthand version. For getting and setting attribute values, the shorthand uses the entity, followed by the @ symbol, followed by the attribute name. The shorthand for getting entities uses the entity, followed by the hash symbol, followed by two characters that specify the type of entity. The first example uses _v, which is for vertices. The second example uses ps, which is for positions. In the second example, no entity is specified before hash symbol. This is equivalent to querying the whole model. Now that we have completed this short recap, let's move on to filtering. Now let's look at how we can use attributes to filter geometric entities. Here is the example from the previous video. We need to get the two polylines for the floor. To do this, we can use the query.Filter function. The query.Filter function takes a list of entities and filters them. It then returns a new list of entities, where certain entities have been excluded. The filtering is performed based on an attribute expression that evaluates to true or false. This expression is called the predicate. The function will apply the predicate to each entity in the input list. If the predicate evaluates to true, the entity will be included in the output list. If not, then it will be excluded. The function actually returns all the stringers. The other two lines of code then extract the first and last of the stringers. In the example, the code first gets all the polylines in the model. It then filters this list using a predicate to check the value of an attribute. In the case, the name of the attribute is name. The query.Filter has a drop-down list, allowing you to select different operators for the predicate. If the value of the attribute is numeric, the relational operators can be used. The query.Filter also allows you to create a predicate that targets an attribute with an index. For example, consider the XYZ attribute on positions. You may want to filter out all positions which are not lying on the floor. This requires you to specify the name of the attribute and the index, which in this case would be 2. Instead of inputting just the name, a list of two values can be input. The first value is the name, and the second value is the index. Filtering is a very common requirement. A shorthand has therefore been created in Mobius for calling the filter function. The shorthand is simply a convenience for calling the query.Filter. The shorthand uses the question mark and @ symbols. The shorthand can be combined with other shorthands to form composite expression. This example can be read as follows. Get all the polylines from the model where the attribute name is equal to strs. This example can be read as follows. Get all the positions from the model where the attribute xyz has a value at index 2 that is less than 1. When passing data from upstream nodes to downstream nodes, there are some good habits and bad habits. The good habit focusing on communication between nodes using attributes. It is good to add attributes to your entities in upstream nodes. This will allow you to easily retrieve those entities in downstream nodes. The bad habit focuses on communication between nodes using explicit entity ID. The polylines created by upstream nodes will all have specific entity ID. The downstream node could therefore explicitly use those ID. In this example, the stringers variable has been set to a list of explicit ID. This will work in this case. But as soon as some changes are made to the model, the IDs are likely to change, which will result in bugs and errors. So you should try to avoid using explicit ID in your code.